In today's lesson, we'll be looking at quadratics, but we'll be looking at them using the vertex form. Our objectives will be to introduce the vertex form for quadratics, to convert from vertex form to standard form, and to identify the vertex when the quadratic is written in vertex form. So let's begin by discussing what vertex form is. When we have a quadratic written in vertex form, this is what it would look like. F of x is equal to a times x minus h squared plus k. And when we have a quadratic written in this form, then the vertex is hk, meaning whatever number is right there is the x value of the vertex, and whatever number is right here is the y value of the vertex. I do want to point out that the a value is still the leading coefficient, and its sign will still tell you whether or not the parabola opens up or down. So let's take an example here, and let's identify the vertex. So if I give you the quadratic function f of x is equal to 2 times x minus 3 squared plus 1, and I ask you to locate the vertex for me, you could tell me that it is 3, 1. So 3, 1 is the vertex, and I've just pulled that from the quadratic function when it's written in vertex form. Now I really do need to make sure that you're convinced that this would work. So we're going to convert this quadratic function that is in vertex form back to standard form. To do that, we would need to FOIL this right here, x minus 3 squared. So I'm going to write it out as 2 times x minus 3 times x minus 3 plus 1. I will then FOIL this right here. That would give me 2 times x squared minus 6x plus 9, and you still have that plus 1 hanging out there. Distribute the 2, and I would get f of x is equal to 2x squared minus 12x plus 18, and I still have that 1. So my final answer would be 2x squared minus 12x plus 19. Now let me stop for a minute and let's focus on what it is I'm telling you. What we're saying is this: we have a quadratic function written in vertex form right here. We have the same quadratic function written in standard form right here. If 3, 1 is the vertex of this one, then it also should be the vertex of this one. So let's just check to make sure that that really does work. If I'm in this form, how do I calculate the vertex? Well, remember, I start by calculating the axis of symmetry, which is negative b over 2a. So a negative 12 would give me 12 divided by 2 times a, which is 2. When I simplify this, I get a 3. And remember, that should be the x value of the vertex. Well, so far things are looking good. And to find the y value, what would I do? I would plug that 3 into the function, and when I do that, I get 2 times 9 minus 12 times 3 plus 19. That's 18 minus 36 plus 19, negative 18 plus 19, for a final answer of a positive 1. And remember, that's the y piece of the vertex. So I have the x value comes from right here, the y value comes from right here. So the vertex for the parabola that's written here is 3, 1. It's the same as the vertex that you found up here. So hopefully that will help convince you that this vertex form really does work. Looks a little bizarre, but it really can help you identify that vertex. Now, with that said, let me go on and let's take some examples now and see if we can identify those vertices. I've given you the vertex form at the top again to help you remember it, and I want to start with this one. First of all, does this parabola open up or down? Well, remember, we can still tell that by this right here. So it opens down. But the next question I have for you is, what is its vertex? Well, I see that this sign right here needs to be a negative, and it is a negative right here. So there's part of my vertex. And then out here it needs to be a plus k. Well, I have a plus 6, so there's the other part of my vertex. So in this one, the vertex is 4, 6. Seems pretty straightforward. Let's take another one. This time I have f of x is equal to 2 times x plus 3 squared plus 4. Let me ask you, first of all, does it open up or down? Well, it should open up. The 2 is a positive 2. And the next question I have for you is, what is the vertex? Well, I do need to point out to you, it's going to get just a little bit more complicated this time. Notice that in the vertex form, that has to be a minus right there, and it's not. So what I'm going to do is I'm going to rewrite this, and this is a step that some of you won't need to do, but I want to make sure that you see it just in case you need it. I'm going to rewrite this as 2 times x, and then this plus right here I'm going to write as minus a negative 3, still squared, plus 4. Now remember, I'm looking for a minus sign right there. I have it right there. So what is the number that is part of the vertex? Negative 3. Out here I was looking for a positive k. Well, I already have a positive k right there. So my vertex is going to be negative 3, 4. Let's do another one where we have to play with those signs a little bit. This time I have f of x is equal to negative 5 times x plus 6 squared minus 3. By the way, it opens down. And this time, notice that this sign is not like I need it to be, and this one is not like I need it to be either. So let's see if we can make that happen. I'm going to rewrite it by saying negative 5 times x minus a negative 6. Now remember, when I do that subtraction right there, that becomes a plus 6. So that's the same thing as what I have written right here. Up here, I need this to be a plus, and the only way I can make that happen is to add a negative 3. So now my question is, if this is h and this is k, what is my vertex? Well, it's negative 6, negative 3. And the only thing that is difficult about this at all is taking care of those signs. So watch what you're doing with them, and everything else should go okay. I thought today you might like a short lesson because we've had some doozies here lately. So let me leave you with my thought for the day. We make a living by what we get. We make a life by what we give. I'll see you again soon. Bye-bye.